So picture the massive jumbotron at a packed stadium or, maybe a cluster of diagnostic monitors in a sprawling hospital wing. You are looking at flawless, uncompressed 4K video and perfectly synced audio, but
But the hardware actually powering those screens is running hundreds or maybe thousands of feet away.
right. Exactly. It's a massive infrastructure challenge.
Oh, absolutely. I mean, in those enterprise environments, you need to move just a tremendous amount of data over extreme distances without any latency or signal degradation.
Which brings us to the mission for today's deep dive. We were looking at the technical specifications for the Smart-AVI HFX-S 4K HDMI over fiber cable extender set.
Yeah, it's a seriously impressive piece of kit.
It really is. It's designed to take uncompressed 4K Ultra HD video at 30 Hz, as well as 3D HD video, and push it up to 1,000 feet.
Right. And it does that using OM3 multi-mode fiber optic cabling running at 10.3 gigabits per second.
So just to give you some context here, if you think about the standard 6-foot HDMI cable you have in your living room, it's basically like a simple garden hose. But this fiber extender, it's more like a high-pressure water main delivering a massive flow of data seamlessly across a whole stadium.
That is a great analogy. The sheer bandwidth is impressive, but, the engineering that makes it work is what really deserves attention.
Because it's not just pushing the raw HDMI signal down a longer wire.
Exactly. It is actively translating the signal from an electrical current into optics.
Well, let's look at that mechanism, because if you are deploying this in a commercial space, shielded copper is pretty much standard practice. So why not just use a heavy-duty, heavily shielded copper cable to cover that distance?
It sounds logical, but standard shielded copper simply can't survive the environments where this extender is typically deployed, like medical campuses or financial trading floors.
Because of the interference.
Yeah, massive EMI and RFI. If you run 1,000 feet of copper past an active MRI machine or, through the walls near an industrial HVAC system, you're dealing with extreme electronic noise.
Right.
And even the thickest shielding can't prevent that level of interference from bleeding in and just completely degrading the signal.
Because copper relies on pushing electrons down a wire. Heavy machinery throws off massive electromagnetic fields, and those fields actively pull and disrupt the electrons, so your data gets scrambled before it ever reaches the screen.
Which is exactly why the optical conversion is the defining feature of the Smart-AVI unit. The transmitter takes the incoming electrical HDMI signal and feeds it into a Class 1 laser.
A laser, wow.
Yeah, it translates the 4K video, along with the Dolby True HD audio, into microscopic pulses of light, firing them down the OM3 fiber cable.
And since photons don't carry an electrical charge, they literally ghost right through those electromagnetic fields. I mean, the signal doesn't care if it's sitting right next to an MRI machine.
Exactly. The environment becomes completely irrelevant. The light travels up to 1,000 feet down the fiber, hits the receiver unit, and then the receiver translates those optical pulses back into the standard electrical HDMI signal for your display.
So you get zero signal drop.
Zero. Alongside high-quality Dolby True HD audio.
Okay, but whenever you introduce active signal conversion, especially translating 10.3 gigabits of electrical data into light and back again in real time, my mind immediately goes to the latency.
Oh, sure.
And honestly, the configuration nightmare. I would expect you'd need a rack-mounted server and some complex software interface just to manage the optical translation and keep the Dolby audio synced up.
You'd think so. But the spec sheet shows a surprisingly streamlined approach. There is absolutely zero extra software involved.
Wait, none?
None. No drivers to install, no IP addresses to assign, and no network configuration.
Wow.
The transmitter and receiver handle the electrical to optical translation natively right there on the hardware level.
So it is strictly a plug-and-play hardware solution.
Exactly. Entirely plug and play.
You just plug the source into the transmitter, run the fiber, plug the display into the receiver, and the hardware microprocessors manage that 10 gigabit conversion instantly.
Yep. The invisible infrastructure is doing all the heavy lifting. The end user just sees a perfect 4K image, completely unaware of the real-time optical translation happening right behind the wall.
It really makes you wonder where this heads next. I want to leave you with a thought to mull over. If uncompressed 4K data and lossless audio can already travel 1,000 feet instantaneously via light, completely immune to interference, how long until this invisible infrastructure eliminates the need for visible hardware entirely in our everyday smart homes?
Well, the underlying architecture is certainly there to support it.
Right. We might soon see a reality where all our processing power is hidden away in a basement server, sending perfect pulses of light to completely wireless screens all over the house.